Hello everyone, and welcome to today's SANS webcast, Hardening Microservices Security, Building a Layered Defense Strategy, sponsored by CloudFlare. My name is Carol Auth of the SANS Institute, and I will be moderating today's webcast. Today's featured speakers are Dave Holzer, SANS Fellow Instructor, Course Author, and Dean of Faculty for the SANS Technology Institute, and Matthew Silverlock, Solutions Engineer at CloudFlare. If during the webcast you have any questions for Dave or Matt, please enter them into the questions window located on the GoToWebinar interface. We will be answering them during the Q&A session at the end of the presentation. And with that, I'd like to hand the webcast over to Matt.
Cool. Thank you, everyone. Thanks, Carol. And welcome to the Security Microservices webcast.
Matt, I apologize. I need to break in here. Your audio sounds really bad. Could I have you switch to telephone? Do you have the ability to do that?
I do.
Hi everyone, it's Carol again. We'll give Matt a moment to connect. Thank you for your patience.
And just while Matt's working on that, as we get started in this presentation today, Matt's going to start by kind of introducing this whole idea of microservices and a little bit about how that's different. But we really want to focus too on what it is we need to focus on when we're moving into a microservices architecture, whether that's because we've been in a traditional service-oriented architecture or we're currently in a monolithic web application architecture today. And are there differences? Are there things I need to care about? And the answer is yes. Many of the things that we find are mentioned in the OWASP top 10 are still very important. And sometimes, at least personally, I find that when we move into a microservice architecture, some of the basics are getting overlooked. Now, when Matt gets back in here, he's going to get that started. In the meantime, I'd also just like to put my email address in the chat window there and invite you that if you have any additional questions, maybe things we don't get to here, or you're investigating microservices now or perhaps in the coming months, please do feel free to reach out to me along the way. I'm more than happy to help you. And I'm sure that Matt and CloudFlare are also willing to help out as well. Let's just give him another minute, see if he can get connected.
Great. Hopefully it's a little bit clearer now.
Much better. Thank you.
Great. Perfect. Great. So thank you, Dave, for covering for that couple of moments. So as I was saying, we obviously the term microservices has seen a huge explosion recently, and as a result, it obviously brings a lot of challenges. There's a lot of questions about bringing existing ways of looking at security. Do they still apply to microservices? Do they not? What carries across? What are all the differences between the way we've been doing things previously, and where should we start looking? Where should you start in sort of the design process to make sure things are secure? So, critically, obviously, what is a microservice? And again, what security challenges do they bring? So microservices are a modular approach to business services. In many ways, it's a reinvention of the service-oriented architecture or SOA model, where you are basically segmenting your architecture into lots of tiny little pieces that are responsible just for what they need to be and nothing else. And obviously, to which degree you take that, what you define as an individual responsibility is very different, or can obviously be taken to the extreme and everything is just doing one piece, or perhaps every service is maybe only just doing three or four sort of tightly coupled responsibilities rather than the entire application. In many cases, you declare API contracts between each of those services so that each service knows how to talk to others. Those services, you can rely that service can continue to talk to others. But internal development, internal deployment is self-contained. Instead of having to deploy and manage, thousands of pull requests, a large application that maybe takes an hour or two to spin up and requires the entire production database to operate, Your testing, your deployment, your development, the whole life cycle of the product is now scoped down to a much smaller service that in many cases, and a large desire to run microservices is that it can run on developer laptops. You can run the service you're building on locally, you can test it in isolation, and then you can plug it into the larger architecture as it needs to without having to sort of coordinate with potentially tens or hundreds of other developers at all points in time so that you're not interrupting their work either. So, of course, many of the benefits, less coupling. So easy to reason about changes. You're dealing with, in many cases, one piece of responsibility or a few pieces of responsibility rather than worrying about how a code change here affects behavior over there. You can apply the most appropriate technology to the problem at hand. So if a particularly performant language or a framework or even a data store works and is appropriate for this and is appropriate for your team, you can deploy that and with this particular service rather than trying to say, well, what's the best general fit for all of this? And maybe you end up with a solution that's maybe only average in all cases as the compromise, and that may not be what you want. And it may hurt you later on as you realize that the choice you made for all of your architecture is causing you pain in particular pieces where maybe performance is critical or maybe developer friendliness is critical in other pieces. Of course, it really does suit larger organizations with multiple teams. This doesn't mean that you can't use microservices in small teams. I've certainly found, though, that jumping into microservices as we want to use microservices doesn't always work out if you're just starting out, and it's not the sort of silver bullet for scaling your architecture. And of course, again, it's easy to test. You've got these individual pieces that you can mock API responses around them. You're not relying on tens or, again, hundreds of other people to help you build and test these things, and you're responsible for your little piece. And particularly as organizations grow and teams sort of, I guess, smaller teams have to shake out of those larger sort of hierarchies, microservices sort of fit with that. Team A is responsible for these services, Team B is responsible for these services. And they coordinate between them, they define their contracts about how they talk to each other, but on a day-to-day basis, they don't have to continually talk, hold tons of meetings to actually get things done. Again, challenges. So lots of moving parts, and this really talks to the security piece. And now everything potentially has an API, is communicating with other things. There's not just one surface to protect, but every microservice, be it a virtual machine, be it a container, however you're deploying those services, now has effectively multiple vectors, multiple communications paths to and from that you need to think about securing. Obviously, complexity is a major piece here. Although there's obviously benefits to running technologies that are fit for purpose and designed to solve the problem at hand, is if you take that too far to the extreme, you're now running 5 or 10 different languages. Some teams can modify things, other teams can't. As people leave, it becomes challenging to look after those pieces of software and critically making sure that they're kept up to date. It might be fun to use a particular esoteric language that maybe a particular team likes. But if there's not expertise across the organization, not processes to keep them updated, your InfoSec team isn't aware that those things are actually in play. When there's a major vulnerability announced with that particular stack or the pieces of that stack, it's now, it could sit there unpatched for a long time and be a major risk for you that maybe comes up months or years later and causes a lot of pain. And of course, there's still the need to have communication. You still need to define or should be defining sort of API contracts so that the services can communicate with each other. And a benefit of having those kind of contracts is that you should really know the surface area, the communications paths for those applications. If you have potentially hidden internal paths, people have created APIs that are only used for some services but not others. That's more things to secure, more things that aren't obvious, more things that sort of filter through or sort of aren't caught by process and potentially end up being security risks. So I'm going to hand over to Dave here. But Dave's going to particularly talk around the threat modeling of microservices and how that's been and how that's moving forward as we sort of look at different kinds of architectures.
Yeah, thank you very much, Matt. You know, as we talk about threat modeling, one of the big things that I'm seeing, and that's really what I want to talk about, is that many times we are not thinking about things the same way an attacker might be doing it. Instead, many of our security systems, many of the ways we design security into applications, whether that's a traditional monolithic application or here dealing with microservices, we tend to think much more at the functional level rather than thinking about the overall threat. So what's the signature rather than what's the behavior? And what we really need to be able to do is stand back and think much more about what it is the application is supposed to do, think about how someone could go about abusing that, and then think about places that we have gaps, places that people actually could do things bad. Now, to illustrate that, we're going to start with something that's very familiar territory, and then we're going to shift over to microservices. Here we're taking a look at a simple network. Forgive me, I'm not the greatest artist, but we've got Wendy and Bob here. We've got Eddie who's on the page. He sent in a phishing email, and that email has got some link in it that someone might click on. And if Bob receives that, he's going to click on that message. Is there a signature here? Well, sure, we could try to use spam filtering and phishing filtering and all that great stuff, but we all know that every one of us gets mail every day that we should not get, because Eddie just has to change the signature a little bit. So maybe that's not the right thing to fire on. It certainly doesn't work. But if we go a step beyond that, the next behavior is that Bob is now going to click the link. So maybe there's something to look for there. Do I have the DNS query going out? But is there a way to correlate those two things, especially when they're so different in time? Because there's no guarantee Bob would click that link within just a few moments of receiving the email. Clearly, there's a big challenge. And then we see the response coming back from Eddie. Now we can associate that IP address and the link that was originally there, but again, a huge challenge. Finally, we have the actual connection from Bob out to Wendy. He goes and gets malware. Now, as I said, this is here just for an illustration. The point is that when we're looking at trying to defend our environments, we tend to be doing it with really simple signature-based things. Is there a firewall that's blocking certain activity? Is there antivirus looking for malware? Is there an intrusion detection system? Is there spam filtering? Those are all great things, but on the whole, they really don't look at the behavior. As security professionals, we tend to look at the single activities rather than the behaviors, and that's something that really needs to change, and especially so when we begin looking at microservices. So let's talk about the threat modeling again. And with the phishing I was just talking about, clearly it's possible to do, but it's the behavior. It's the email with a link in it, a following up DNS lookup, and then finally a connection to that IP. No one of those is really the right signature, but all three of those tell us something bad is happening. In the microservices world, we're moving from using monolithic web applications to a distributed sort of approach. The whole idea of microservices, or at least one of the main ideas in microservices, is that we should seek to do just one thing, but make sure that we do it exceptionally well. While that's not difficult if we're talking about something that returns the current weather or a stock ticker as part of a much larger application services framework, the security, when we start dealing with sensitive information that's sitting behind data stores or business processes, really becomes important. In traditional web applications, session issues are well known as a serious vulnerability. They've been in the OWASP top 10 ever since that first got started. In the microservices world, while we don't have an OWASP microservices top 10, we could say that many of those same things come directly over to microservices, though it can be more challenging sometimes for the developers and even the security professionals to see how that works. For instance, in dealing with sessions with microservices and authentication into applications, let's just do a little threat modeling for a second. Here we have Bob. Bob is going to authenticate out into some kind of a server, so we've got Sarah down there, and in the process of doing that, he obtains some kind of credential. This could be as simple as there's an OAuth process in place, and he's now got an OAuth resource token that's going to be presented to each of the microservices. Great, no problem. Bob now goes out and talks to Mary and says, hey Mary, I want to get this microservice that you published, presents his resource token, and he now gets that information. The problem is, though, that this could be leveraged by an attacker as well. all Eddie needs to do in this case is to either brute force, capture, or otherwise guess what that resource token is. Now, I'm not talking or suggesting that OAuth tokens, for instance, are not secure. It's that the idea of stateless applications in web applications is understood and often concealed from us by our web application development tools. In the microservices architecture, however, it is really put right in our face. This is absolutely a stateless environment because there isn't just one Mary. There could be hundreds of Marys sitting behind maybe an API gateway or perhaps just the application itself, subscribing out to many different content providers as resources. So how is each one of those Marys to know if this is actually Bob and that no other service has somehow compromised that token? Of course, the more users you have, the more likely it is that a token could become compromised, and any weakness in any one of those many services you have could potentially lead to one of those credentials being exposed. Now, when we talk about doing the threat modeling on this, the idea is actually a little bit different from the way most people approach it in monolithic web applications. Clearly, if someone is attempting to authenticate as a user and they fail to do that several times in a row or a large number of times over a long period of time, we absolutely know there's something wrong. We would maybe blacklist the user or blacklist the IP address or whatever we would do. But quite often, my experience, both as a penetration tester and as someone who consults with companies to either build large scalable applications or to help their developers become better at secure coding, my experience, they only think about the front door being where you put in the username and password. But where we are right now is talking about the sessions. One of the ways to approach that, obviously, is through API keys or through OAuth tokens and things like that. But how critical does it become to really protect those API keys well? One of the approaches that some are using is to look at that problem and actually use the same approach we use for cross-site request forgery. Because essentially, that's what this can become. One of the things that it can be natural to do in a microservice application, especially one where you're trying to make it available to many things rather than just narrowly offer that service to your own application, is to whitelist many addresses or sites, possibly even whitelist the world. In the process of doing that, we really do create a situation where someone could, through another application, use or just pass through the credentials of an already authenticated user, effectively in a cross-site request forgery attack. So then the solution, much like we would use in CSRF, is simply to add some kind of a token in there, like a CSRF token, that can then be validated on the back end. While that does add some computational complexity and certainly some load on the back end, we are also distributing this across many different servers rather than just having it in a single monolithic application by the nature of the microservice architecture. Clearly, though, this does lead to some other issues too. This is not a brand new issue for sure, but it is definitely an issue that comes right into the forefront when we're dealing with microservices, perhaps even more so than it used to be with the monolithic web application. Because with the monolithic application, I can see all of those requests coming in one place, and now they may be spread across a very large architecture. Clearly, though, this does require that we are far more threat-focused when we're writing our code. Now, with regard to this, Matthew, what recommendations are you making when it comes to securely authorizing transactions in microservices?
Thanks, Dave. So there's a lot here, and thank you for sort of, I guess, highlighting the way that multiple services tie together. So in terms of recommendations, I think it's really important to, and this is sort of leading to the next slide here, is offload as much work as you can to the network edge, be that on the edge of your own network where your authentication services lie. You're looking at your firewalls, looking at your rate limiting mechanisms, be it potentially a network provider and CDN service like CloudFlare, obviously, but you want to do a lot of that work before it even hits your services. You'll have a lot of pain there when you have unfiltered traffic that you're not sure whether it's good, whether it's bad. You don't want your authentication service, which is often the first thing that many users hit, to be the point that needs to decide that you don't want to create unnecessary load on your network before it then filters into the rest of your services. And if they are running on a shared platform, be it in your own data center, be it on a cloud provider, they are still sharing the same, they're coming from the same credit card, they're coming from the same compute resources in many cases. They might be running somewhat on different machines, but there's going to be some shared bottlenecks there, potentially a lot better than monolithic applications of old, but they still do have that kind of sharing at sort of a larger scale. And if you have those bottlenecks, if you're not filtering things on the edge, you really are going to see a lot of pain there. One thing particularly I want to ask you, Dave, is what are your recommendations in terms of testing at scale, not just sort of throwing more services or nodes at the problem?
Matthew, that's actually a critical thing that I see. Our organization just finished a pen test of an organization that is essentially creating a fledgling microservices application, even though it's only their application that subscribes to it. And of course, the advantage that we can now push that out to many developers, having them all work on it, and that's all great. But what I'm finding is that when we actually go in and test those applications and test them working at scale and all together cooperatively, organizations are not sufficiently dealing with how it is that where the load actually is in the application. It is entirely possible that it's necessary to horizontally scale out, but more often we find that because it's so broken down, very little effort is taken to really optimize the most critical paths within the code itself. Is there anything that an edge provider like CloudFlare or others can do to assist people with this? And what are you seeing people do that you interact with?
Cool, thanks, Dave. So what we're seeing, and this sort of again touches on that resources piece, is it's great to think that everything can scale horizontally and every service can spawn more copies of itself, and your orchestration technology, be it a container piece like Marathon or Kubernetes, can spin more containers up. But each of those are scaling in isolation and not considering how they fit in the whole. You're going to see a lot of pain. It potentially can amplify the effects of DDoS attacks, as you can force intensive services to consume resources for other intensive services. So hitting paths that would always hit your database, hitting authentication services that are maybe looking at doing sort of key signing or validation operations that may be a little bit more expensive, but often worthwhile in the larger scale to make sure things are secure. Potentially even identifying what services might actually be stateful services rather than stateless services. Go back to that database piece and attacking those. So the things we suggest considering are focused heavily on the DDoS protection, particularly again looking at your firewall pieces. CloudFlare has a web application firewall that is designed to bounce a lot of traffic at the edge before it even gets into your network, let alone actually hits your services, which obviously is sort of a two-part play there, in that it's securing things but also hopefully saving dollars. So you're not spending it at your cloud provider for traffic that's not actually benefiting users or actually helping serve your application.
Oh, that's excellent. One of the other challenges that I'm finding is that people, well, it's even what we were talking about, they're simply not thinking through the threat modeling beforehand and in development. Are you seeing that happen too? Is there anything you're doing to assist people that you work with?
Absolutely. So, in many cases we're looking at and providing some advice on how their applications do sessions. We're looking at really making sure that TLS is a major piece of your infrastructure, and not just on the edge where we can help do that, and obviously when we communicate back to customers that there's TLS all the way through and using the most modern protocols and cipher suites, but also that sort of suggesting in many ways that people should be using it internally, is that wherever possible your services should be talking TLS between each other, be talking not just encryption but also authenticating as well. So you have those multiple layers that you've got your transport layers, which again, often TLS. You've got your authentication layer so that each service is sort of authenticating itself with others, and you're not just assuming that once things are, that services once inside the network are free to just talk to anything else. You should assume that at any point in time it might actually be an external entity talking to those internal services, particularly again as development becomes more focused on teams and more focused on individual services. Sometimes that communication about the kind of data being accessed and where it's coming from can be missed. And that sort of leads into this piece around protecting your data. A major piece is that every service might actually back onto a shared database or other kind of data stores, be they NoSQL, be they things like Postgres. But if all of the data is in there, if everything from your billing data, from your session data to PII, so personally identifiable information for customers' email addresses, what controls are you thinking about in terms of each service accessing only being allowed to access just what it needs? Does it make sense in many cases to have a shared data store? Maybe there's some benefits to splitting those out to provide some isolation there as well. Again, going back onto resource exhaustion, perhaps services that are hit regularly like session stores, stateful sessions, should be divorced from other parts of your application so that load, any pain felt there isn't impacting other operations across the network. So Dave, what have you seen in this space here? What are the sort of the common pitfalls when sharing data stores across dozens of services? What are some of the ways to sort of, I guess, solve that that you've recommended to people or have seen people employ?
It is a really big problem, Matthew. And if you're following along and you're not exactly sure what the issue is, if you wanted to point to an OWASP thing, the OWASP thing would be a direct, and that is the #1 thing I see happening. Because as we move into these microservices, it is extremely common to find that we have a Redis or other kind of NoSQL or document store sitting behind it, meaning that we're using GUIDs and other kinds of things to track things, and that it's not a traditional structured piece of data, but instead it's just an amorphous blob of stuff. And as you're saying, if we've got all those things sitting in one data store, ultimately we could end up with a situation where people are able to access data out of really a different object that they shouldn't be able to touch normally, simply by manipulating the GUID. Of course, the same thing would be true with a traditional service because we would just have the ID, perhaps, of the record sitting in there. I do see it quite often. Again, we just finished that same pen test where we are able to simply manipulate a GUID and begin editing other users' data. It is an extremely common problem. And if you're thinking about a GUID, some who are listening and thinking, well, those things are huge. How could you just guess another one? It's not easy to guess another one with a small data set. But the more data you have sitting behind it, especially when you're talking about a stateless protocol like HTTP with microservices, it becomes easier and easier to get a valid GUID that isn't necessarily the kind of object you were looking at originally. What we've been recommending to people is to just take an extra step of adding some additional reference points within the data itself, so that within the microservice endpoint within the provider, it's validating that the data it's getting still matches up with the security model. In other words, the person's actually authorized to view or edit or whatever else that particular piece of data, in addition to traditional validation, proper size, type, and range. So is that object you're pulling out of the data store actually the kind of object you expect it to be? It does add a little bit of a load into the individual services, but I find the bigger problem is that it requires that we really have solid templates for the development of our services. So as a new service is being developed, no matter what language the developers are going to use, we have a solid set of standards, perhaps even built in with an API, a library, if you will, that they're going to rely upon to make sure that those kinds of issues, are addressed. Is there anything additional you're recommending, Matthew?
Yeah, absolutely. So, and this sort of actually leads into the next piece. So we've spoken a lot around authenticating endpoints. I think we've both seen, especially yourself, Dave, is that this is critical. Is you might run dozens of services or potentially hundreds in a large organization. You shouldn't make any assumptions around what's trusted and what's trusted. Don't trust anything landing in the services. Require authentication. Have ways to revoke credentials as well, be they from users as much as you can, be those from individual services. Potentially, if a service is compromised, you don't want it to be able to access for the duration of a auth token or a bearer token other services, and that could be, it might just be hours if you've kept them short. It could be minutes, but there's a lot of damage potentially can be done even in those short time frames, let alone the traditionally sort of hours or weeks longs that you often see out in the field. And this sort of touches again on, particularly with containers, which is obviously a common way for people to deploy microservices, is you now have all these dozens of services. As we said before, they're running potentially different technologies, and in the container case, they're potentially running different images. They're running different services. They're running different platforms, different operating systems. You now have, in a real-world case, you now have dozens, if not more, versions of OpenSSL to patch. So every time there's a major, critical vulnerability or a serious vulnerability that is potentially critical to your organization, depending on how you're using libraries like OpenSSL or the applications that leverage OpenSSL use it, you have to patch all of those. You have to identify all of those. If you don't have processes in place to identify where every service is using those kind of dependencies and ensuring they're all updated as quickly as possible at the same time, it only takes one outdated microservice or container running a vulnerable version of software to potentially compromise large parts of your network if you haven't robustly thought about previous things we've talked about, which is authenticating traffic, scoping down access to data stores, and making sure that when services access data, it's only the data the service should access and nothing more. You should be thinking about it at every different layer. You should assume that perhaps your data store access processes aren't perfect, and in the real world they often aren't, and that's reasonable. And perhaps there's a couple of points where some unauthenticated traffic is allowed, and maybe everything isn't robustly checked on every request that it's authenticated. So you should assume the other part is everything actually up to date? Is everything running the latest version? And how do we go about just even assessing what's running across all those services? If that's not clear, then that definitely needs to be solved before or as you look at the other pieces. Otherwise, there's going to be this large sort of underlying risk there. And this goes into the next piece, which is, again, knowing what you're running. In this world of microservices and containers, it's often, if you're familiar with like a Docker file, saying, from Debian latest or from X service and getting the latest version sounds great, and every time you build it, you're always getting the latest version, and you might be testing that. But do you know what the difference was when your microservices build systems is pulling down the latest things automatically? You never probably get a chance to actually see what the changes were. Maybe the latest version actually introduced a vulnerability, and if you're pulling things down, from hour one, as soon as they're released, you're sort of sitting in that pool there. You're not quite sure what's actually landing on you, and maybe those services you're pulling in and dependencies you're pulling in are pulling in others. So you should be very, very careful about, or just be confident about what you're running, and make sure you're sort of understanding the risks involved with running these microservices with your teams pulling in different dependencies, and having processes in place to review things as you add them to your stack and run them on your network, and as they touch user, customer, financial data sitting internally. One thing that we found works really well is making sure that there's a strong review process, that it's clear who owns those services and who's responsible for that, and going back on what you said, Dave, which is having these sort of templates in place, is saying, hey, this is the way you access data source, and it's managed by this team, so you can access any of the services you would like, but you have to follow this approach. And they are responsible for patching those data stores, making sure that it's the latest version of Postgres, that it's patched, rather than perhaps maybe relying on every individual team to look after everything they need to manage individually, and obviously things do fall through the cracks in those kind of scenarios.
Yeah, that
And
makes a lot of sense. Oh, I'm sorry.
No, sorry, go ahead, Dave.
That makes a great deal of sense. Related to that, a common issue that I run into is folks are pulling things directly out of a content delivery network. So it may not be that they're immediately deploying the newest version, but they're absolutely deploying out of a CDN, which requires that they whitelist the CDN for their application to function if they're using, for instance, a JavaScript front end or something like that, which leaves you open to potentially having some kind of flaw that gets exploited that leads to cross-site scripting or something along those lines. A really notable one that came out with Angular that drives right to your point was last December a security researcher with permission managed to introduce a non-breaking change into the Angular framework that reintroduced the flaw in the sandbox. Of course, he let them know about it right away, but that led directly to this issue of I can now inject my own load commands out of a CDN and even load an older version with known flaws in it, which will typically load first, being smaller, and some of them actually include, the more modern code, include some analysis within them to verify that there isn't already a function with that same name, which means that the first one loaded, the smaller one, the old, is the one that's going to win. And that'll have the flaws in it and pull them right into your microservice. So I'm sorry for interrupting you there, Matt.
No, that's a really good point, and I think as we see a common case for using sort of microservices or sort of API-driven development that sort of goes hand in hand is often with these sort of single-page applications, these JavaScript sort of frameworks, and this often sort of touches on the assumption that your front end, your GUI that you've built maybe in JavaScript or otherwise is the only thing accessing your services. Maybe you don't actually expose a public documented API, but it is right there. It's the same thing that your application's accessing through the browser, and you need to consider how not just how your application uses it, but how somebody who can look at the API endpoints through the browser, through the web inspector, and what they might be able to do with those. Given the ability to iterate over IDs, given the ability to brute force them, they're not a friendly person, a friendly developer that's just designing things in the scope of your application. They now have these APIs they can do anything with, and maybe they even have an authentication token that they've pulled from the browser into their tooling, and are now trying to use that as a privileged user to attack other things. And again, this is really important to make sure that every service really only has access to the secrets it needs. So not just the data, not just the user data, the financial data, any other sort of data it needs to pull down to operate. Actually, the secrets it needs. How are you deploying this? Does every service reach out and just on request get everything it needs? Is everything built into the base template so that every service just runs with credentials to access every other service and every other data store? Maybe you've actually scoped down and said, hey, this particular service, this authentication service can only hit the authentication and session store. It can't hit any of the direct user data stores. But if the credentials are built in there, the next step is if somebody compromises that service or finds a way to get it to do things that it shouldn't be doing, it still has the keys to access the rest of the kingdom. And it's really important, and I found this is really critical, is to really understand how things can be revoked. This again touches on Dave's piece around how stateless services are really important and how they often, prior to microservices, could be somewhat implicit, and it wasn't clear what was stateless and what was stateful, and many services, particularly in sort of times of old with cookie-based authentication, were often stateless, and your ability to revoke credentials was challenging. Moving forward, with the advent of sort of things like OAuth tokens, they can be revoked depending on how you've built them. And if they can't be, you need to consider the benefits there that you've traded off. I don't have to hit a data store in every request, and that's less load. There's some performance benefits there. But if somebody had that key for, again, a matter of minutes, hours, days, and I can't actively revoke it, perhaps maybe unless I actually say revoke everybody at once, which could have some obviously some large impact to your customer base, and potentially even make the decision harder. It may take some further approvals if you have to revoke everybody's access at once and require all of your end users or services to re-authenticate. During the time as you're trying to decide that and get those approvals and understanding the impact, you have those effectively those compromised credentials out there that could be used on your network to do some not so great things.
Well, it is extremely important. One of the things that was running through my mind, it's related to revoking, but not just the OAuth tokens, just the overall idea of using microservices within an enterprise application, whether it's an internal or something that's external facing, is super common problem I run into is that the individual services seem to quite often be unaware of the fact that someone has not been revoked, but has ended their session. Because again, it's communicated across the entire, or needs to be communicated across the entire application. There's something else too, where you were talking about how only our code can access it, and that view that only our code can access it. Not to beat up on Angular too much, but that's one of the reasons they're one of our favorite applications to test these days. The developer feels as though their API is somewhat concealed, but if you're dealing with a single-page application out of Angular as part of this microservice solution with providers sitting in the back end, you really are publishing your entire API, even if you're not accessing it, because it's quite often sitting right there in the single-page application. And it's just a matter of kind of shoehorning your way in and convincing the application or the service to talk to you, which may not be that well secured. Matthew, do you have anything additional you'd like to add, or would you like to field some of the questions we have that have come in?
I think you've wrapped it up really well there, Dave. So very happy to sort of field some of the questions that have come in, and hopefully we can provide some quality answers and address some things that maybe we haven't covered yet.
All right. So we've got an interesting one here from Martin. It's sort of it's not exactly off topic, but it's a related thing. He's saying, are we into reinventing the CAN bus problem within the automotive construct by using microservices? One of the problems with CAN bus is that security constructs become more burdensome than the data within a transaction between two endpoints within the car. So do you have any opinions about that, about how the distributed model within microservices really impacts us with the security?
Yeah, I think that's actually a really good question, and I think particularly over the last few years we've seen, particularly with CAN bus, actually there's been some vulnerabilities with the way that modern manufacturers have implemented that, which does obviously have a strong correlation with the way microservices can be done, where the process becomes so burdensome that there are ways around it, that you're skipping that process and introducing a whole bunch of potential vulnerabilities. So it's always a fine line, and it's different for every organization into how strict those processes are, how formal those contracts are. But certainly having a good security, I guess, infrastructure, a good processes for security, and having developers see it as a benefit to their applications, seeing it as a benefit to the way that teams operate, rather than a burden to getting things released, rather than this checkbox that you need to get through, so you can actually release your software, and potentially it can feel painful if they're spending days or weeks working on the authentication pieces and the way securing things instead of in their minds the actual service and what it should be doing, and the actual operations it needs to be performing. It can be pretty painful, and that's when you start leading to these ways to sort of skip things and introducing a lot of pain. So hopefully that's answered the question.
No, that's a fine answer. We've got another one that's pretty good here too. It's asking, he says he appreciates, offload to the network edge as part of a layered defense. He agrees completely. He says it's a necessary layer, he knows, but especially because this becomes a really indefinable perimeter when we're dealing with cloud and Internet of Things. He's asking, what if you can't offload it to the network? And I'm going to throw that to you in a second, but for me, one of the ways I approach that, because I find that while microservices are wonderful for creating very, very focused services, provided you have the strong template sitting behind them, where we're governing how not just how that API will talk to other things, but how that API itself must be written, how the service must be written. I still do prefer to put an API gateway, and I may have used that word before. It does create a central point through which all of the queries are now sent within the service, but that itself should not create much of a bottleneck. It certainly is a choke point, but that's something we can scale out, and additionally, it's doing very, very limited processing. It's essentially just validating that this is a request that's authorized, and if it is, it hands it off to that microservice. It's just routing it out there, perhaps transparently, and proxying the data back. So that's one of the ways that we do that when offloading to the network edge just doesn't work. Do you have any suggestions, Matthew?
Yeah, I do. So that's a great question. So I definitely agree. I definitely agree that there are many edges to a network as well. Is that it may be someone like CloudFlare or another cloud provider that's sitting at the outset and bouncing a lot of traffic, but then you have that next layer where you actually have authenticated traffic coming in, and you're confident that for the most part it should be let through, or that it's reasonably legitimate traffic. Having an API gateway on the edge of your own network as well allows you to log everything centrally. Every request coming through, you can log that event. You can make sure, okay, it's landed on the public API or the edge of our network, and we can see it here, and then you should have a hopefully correlating log with one of your services as to how that's come through, and you can track requests as they come through the network. Make sure they're landing on the right points. Make sure they're not failing in between services, which is not just about the security, but also just about having a robust service that's actually available. But I definitely agree that having a reasonably lightweight API gateway that can do some of the core pieces, it sort of, I guess, sounds like an anti-pattern that microservices should be distributing as much as possible. But there are still some benefits to centralizing some of these pieces, and it doesn't mean that it has to, in particular, just be one individual service. It could itself be horizontally scaled and running multiple instances, but it should be lightweight. It should be doing some of the core pieces that give you that ability to inspect things, follow things up later, and troubleshoot issues across the network.
Yeah, that's excellent. The next one I have is it's a bit longer of a question. It's a little bit related to what we were just talking about. Martin asks another question. He says, as an example of security problems created by microservices is the proliferation of content delivery networks. And he's mentioning that when we deal with cloud services, many of them are using CDNs, but not really looking at the implications of ACL access for controlling access from certain networks. He's wondering, why does it seem that everyone considers that cloud and internet is okay, that you can just do those two things with a CDN? And he wants to know what we can do about that, and who it is that we think should take up the torch to lead toward least privilege, both inbound and outbound. What do you think about that?
That's another good question. So, what I've seen is that as people migrate more things to the cloud, which we see as a positive in many ways, and obviously having to run your own infrastructure, and maybe it's not your specialty, and you don't want to be running the infrastructure, but building the product. At the same time, you need to obviously be wary about who has access to this. Again, access control being a sort of a core theme that's obviously sort of coming out of this. You want to make sure that whoever accesses to the services, you know exactly how that's scoped. Whether you're running it in the cloud, whether you're running it locally, I think the same sort of priorities apply, in that you should be running a whitelist only approach rather than blacklisting things. You should be planning out exactly who should access the edge, and maybe that's the internet, but then every step along the way you should be considering, okay, great, after it hits that, maybe only CloudFlare should be talking to my actual servers behind them. There's no reason anybody else should be talking to us but CloudFlare. Or maybe it's another provider like Amazon or Google. We know that everything should be filtering through them, through that cloud provider. So once it lands on our own internal network, or once it even lands on our services running in their respective clouds, that traffic should be coming from the internal network only. And having those sort of layers of access control, again, going back to things like API gateways, which can sort of provide a form of like software firewall in many ways if you don't have the ability to deploy a hardware firewall in those kind of environments, is still really critical.
All right. Well, thank you very much. I've got just one or two other questions here. I think that'll work out well. If anyone has an additional question, now is the time to put it in, because we're just about through here. The question I've got is, how is it that, that people dealing with microservices should go about ensuring that internal websites and admin URLs aren't accidentally opened up to the internet via microservices?
Yeah, so this is one I'm, I guess, deeply familiar with. So I think it's really critical, again, to not just trust that things are authenticated, but that you've got the concept of scopes. And how you're issuing those scopes is not to be confused with how you're issuing tokens and scopes and effectively permissions to outside users. You should aim as much as possible to have those services be divorced. Is the system that issues tokens, access control, authenticates the public users that are trying to access your platform should be very, very different from the system that, at least in terms of operationally how it runs, very different from the platform that authenticates your internal users. They should be different keys. They shouldn't share privileges. You shouldn't have the case where, maybe it's one OAuth scope away from a regular public platform user being an admin user. Those are the kind of things that are very, very easy to make mistakes in. Potentially a couple of lines in the code that's checking a particular condition or a particular flag, or a network address is missed, and you're accidentally applying that admin scope to all of the tokens you're issuing. That can be particularly dangerous.
All right, excellent. We did have another follow-up that came in with the idea of the API gateway. It's saying that the problem is that when you're dealing with endpoint providers, you're dealing with massive IP space. So he's saying it sounds like API gateways and acting as an IP proxy might be a solution, but how can we encourage providers like CloudFlare to advise their customers to utilize API gateways in the right manner so that a limited scope of IPs are required in the ACL? Additionally, is it difficult or costly for an endpoint provider to provide such a service to their customers?
So that's a really good question. So and there's I guess there's two parts here. Is understanding what lives on that IP space from the provider. Do they own their own IP space like Cloudflare? Can you trust that when they reach out from particular IPs, it's going to be just them and not actually other customers potentially on their network? If you were to say with a AWS or a Google case, if you were to just whitelist all of the significant amount of IP space they have, it could actually just be anybody else's services reaching out. So those are definitely important considerations, and I think making sure you can scope that down, asking your provider, what are the ways that we can, when we're creating these ACLs, these access control lists, we can keep them as sort of tightly scoped as possible. And in the case that you can't, what are the other ways or the other layers you can add to that to sort of verify and firm up that ACL, be it based on not just the AS number or the subnets or the IP space that they own, but perhaps there's actually potentially credentials being passed in requests, other sort of elements of the request that you can use to validate that it is just them, that it is not just other customers on their larger network trying to connect directly to your services.
All right, excellent. Well, thank you very much. How about I throw you just one last question? If you have any final comments after that, I think we're just about finished. We have an additional question about how easily someone inside of your network could get access to traffic between the services, especially since we're exploding out into not being a monolithic application, but really being distributed across many different endpoints.
Yeah, this is a really important piece, and this is something that we take really seriously when we build, obviously, a lot of our services, is that any staff member shouldn't just be able to, or anyone running a service on your network shouldn't just be able to arbitrarily connect or read, look at the traffic or other services that are running nearby or on that same network. That could be something as detailed as sort of obviously looking at VLANs and scoping down network access to sort of private networking between microservices or containers, and using sort of orchestration systems that exist to make that easier. It's obviously also about having a good security culture as well. A lot of this can be solved by technology and access control lists, networking, authentication, authorization, but also having a culture where people shouldn't have to feel that they have to actually have a look at things directly running over the network as well. If they actually have to do that, are they trying to solve problems that maybe aren't possible to do through existing administrative tools, and the only way they can get the information they need for their job is to inspect the network, as frustrating as that might be? we should be considering what is driving people to try and access things between services. And in many cases, what shakes out of that is also when an external, potentially attacker, is trying to sort of inspect that traffic and is coming in and saying, well, hey, I want to actually have a look at the traffic as well. If you have those good processes, if you have those access control lists, those private networks in place, they're going to go a very, very long way to mitigating those attackers trying to do that.
Excellent. Well, thank you very, very much, Matthew. It's been a pleasure being on the call with you. Did you have any last comments you'd like to make?
I think probably the takeaway from this is to, when you're looking at a microservice architecture, be you starting out for the first time, if you're a startup, or you're moving from a monolithic application or other kind of architecture, and looking at sort of maybe solving some pain points where having everything centralized has made development or testing or securing things frustrating, is definitely don't, I guess, assume that immediately that microservices are going to be a silver bullet. The takeaways from this, as you've said, Dave, is having some strong templates in place to make sure that the microservices and services you build today, and the ones you build tomorrow and the ones you build next week, all sort of share the same process, that they aren't being islanded as development continues, and such that a service you build this week and a service you build in 6 months' time, the one you build this week doesn't end up being this vastly insecure piece of software that's running old libraries that isn't kept up to date because it just didn't have the chance to, or you were just sort of finding your way in how you were going to build and implement microservices in your architecture. Again, you now have multiple sort of, I guess, areas of responsibility. Teams are looking after their own things. But that doesn't mean that there shouldn't be some kind of, I guess, for lack of a better word, sort of monolithic processes that make sure that everyone's sort of working towards the same goals.
Excellent. Well, thank you very much. I would like to remind everyone that my email address, I'll put it in there one more time. If you do choose to email me, please do put SANS in the subject. Otherwise, it may not survive the spam filter. But if you have any additional questions, perhaps, that we haven't touched on here, or if we didn't have time for your question, feel free to reach out to me. And if it's not something that I have an answer for, I'd be happy to forward that over to Matthew. But with that said, let's turn our attention back to Carol.
All right. Well, thank you so much, Dave and Matt, for your great presentation, and to CloudFlare for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, you can visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.